We're going to be talking about continuity, and in this case we'll start off by mentioning what discontinuity is. So a function is discontinuous at a particular x value if we need to lift our pencil at that point in order to keep drawing the function. So there are several things that can cause a discontinuity at a value x equals 8 for a function. Their first type is that there could be a vertical asymptote. So suppose that we've got a vertical asymptote, and we'll call this case A. Suppose we've got a function that looks like something like this, and it's got this vertical asymptote at this value A here. We'll notice the discontinuity. The left side of the graph shoots up, the right side of the graph shoots up, both going towards infinity. So notice how when we draw that, we'd have to lift our pencil. Second case, is a piecewise defined function where it abruptly jumps at a value x equals 8. So suppose we're moving along, and then we've got this little jump here, and there's our graph. Notice we had to lift our pencil once more because of that jump. So that's the second case there. That is case B. And then finally, suppose there is a hole in the graph. So suppose we've got a function that looks like this, and notice that hole right in between. Okay, so this is another discontinuity. Notice the jump of our pencil from one side of the hole to the other. Okay, so that was the last case. Now it's important to note here that polynomials are continuous everywhere. Okay, so that's something to keep in mind as we're working through example problems later on. Alright, but let's go ahead and take a look at an example now. In the following example, we're asked to sketch the graph of the function and then note the positions of any discontinuities. So we've got the function f of x equals x over x squared plus 3x minus 18. Rational function here. Alright, well it's going to be important here to factor the denominator. So if I were to factor the denominator here, what would I get? Well, let's see. This one should factor pretty easily. I want the factors of negative 18 such that when added give me 3. Well, the numbers that give me 18 are 6 and 3. And to have a negative, well, I must have a negative times a positive to give me negative 18. However, the difference there is 3. So it's going to be here in this case x minus 3 times x plus 6. So very simply put, my factors in the denominator, x minus 3 and x plus 6. Now be sure to review some videos on factoring if you're still having questions on that. But otherwise it's relatively easy. Now in pre-cal, you should have learned how to graph these kinds of rational expressions. So let's go ahead and take a look here. The denominator here will denote any kind of vertical asymptotes that we may be having. So in this case, x minus 3, well, setting the denominator equal to 0, x would equal to 3, and in this case, x plus 6 equals 0, well then x would equal negative 6. So these are our positions for our vertical asymptotes. Okay, so let's go ahead and plot out our asymptotes real quick. So we're going to have an asymptote at x equals 3, and I'm just going to draw a dashed line here to denote my asymptote. That's at 3, and then at 6, so that will be right about here. Okay, so there we go. There are two vertical asymptotes. Now our function, just so you get a feel to graph this, well, notice that we're going to have a 0, a root, at x equals 0. So our graph's actually going to go through the origin there. And it's going to look something like this. So it'll shoot up something like that. And it'll look something like this here. And like this here. All right, notice that it also has a horizontal asymptote. And again, you can kind of figure that out again from pre-cal by looking at the x and the x squared terms right in here. And there's actually a trick to this to figure out how we also have a horizontal asymptote. But for now, this is what the graph looks like. And we're going to go ahead and take a look at the second part of this example to observe the limits of the graphed function. So it says, just by observing the sketch in the first example, determine the following limits. They want to know the limit as x approaches -6 from the left-hand side. Okay, so let's see here. We're approaching 6 from the left-hand side. So here's my mouse. So here is 6, and I'm approaching 6 from the left-hand side, so here it's coming. And where does it go off to? Well, it continues off to -infinity. So as we're approaching from the left, we go to -infinity. Okay, very good. Now let's see, as we approach -6 from the right. So once again, here's -6, and we're coming in from the right. And where do we shoot off to? Well, we shoot off to +infinity. Okay, so we're going to +infinity there. Okay, next. Now we're going to go to 3 from the left. So here is 3, and coming in from the left-hand side. Okay, so here we're coming into 3 from the left-hand side, and we're shooting down to -infinity. Okay, so we're going towards -infinity in this case. Alright, very good. Now we're approaching 3 from the right-hand side. So once again, here's 3. Coming in from the right, we move up, and we're going towards +infinity. So we're going to write that down, +infinity. Okay, so let's see here. Now what about this limit as x approaches 3 of the function in general? Well, let's look at the left-hand side limit, -infinity, and then let's look at the right-hand side limit, +infinity. Notice this goes to -infinity, this goes to +infinity. Ask yourself a question. Do these two limits equal each other? Remember that in order for the limit to exist in general, the left-hand side and right-hand side limit must be equal to each other. In this case, they do not equal each other. Therefore, the limit in general as x approaches 3, we would say, does not exist. Very good. Now, the next question is, what is f evaluated at 3? What is f of 3? Well, notice that this function comes really close, and this one comes really close to some value here at 3, but does it ever touch it? No, because the graph goes off to +infinity on the right hand side and to -infinity on the left. So they're asking, does f of 3 exist in this case? And in this case, it does not exist either, since it's not defined at the value of 3. It comes very close, but is not defined. So I hope this helps clarify any understanding on continuity.
Made with Doodlecast Pro.